So now we'll do the derivative of tan x, but not from first principles, using rules of differentiation. So how do we find the derivative of tan x with using rules of differentiation? So remember that tan x is the same as sine of x over cos x. And also remember that here the x is in radians, so it's a real number. So how do we do this? We know that when it comes to a quotient of functions, we have to use the quotient rule of differentiation. So to differentiate a quotient, remember, we write this like this. We take the bottom function and write it as it is and multiply it by the derivative of the top function minus the top function as it is multiplied by the derivative of the bottom function, and then we divide by the square of the bottom function. And if you simplify this, it becomes what? So focusing on the right hand side, it becomes cos of x, and the derivative of sine is also cos, if you remember from previous videos. Then here we have sine of x multiplied by the derivative of cos is negative sine of x. Now all over the cos of x squared is cos squared x, in short. Now if you simplify this, you get cos squared x. Sorry, cos x, not cox. Then negative times negative is positive, so we have sine squared x. And all over cos squared x, and this becomes what? 1 over cos squared x, which we can simplify to be 1 over cos x, or squared, which is basically sec squared x. And that is the same derivative we found from first principles, if you remember. And then similarly, you can find the derivatives of sec, cosec, and cot. So you just write the sec as 1 over cos, the cosec as 1 over sine, and the cot as 1 over tan. And you use the reciprocal rule of differentiation, or you can still use the quotient rule, but with one function being equal to 1. Okay. So I'll take just an example of doing the sec, and then you can have the cosec and the cot to do by yourself. But I'll also have some more videos where I do that. Okay, so just to do the one for sec, I'm going to erase here. So to do the derivative for sec, we have d dx of sec of x, sec x with respect to x is going to be, we know that sec is the reciprocal identity. If you remember reciprocal identities from grade 10, sec is 1 over cos x. Of course, if you are doing the CAPS curriculum right now, we don't really do reciprocal identities, but I mean, this is for those who know reciprocal identities. Okay. But if you're doing first year, second year, this should be something you've done. The reciprocal identities in South Africa. If you're in another country, you probably have done this in grade 12. Right, so the derivative of this, using the reciprocal rule, we know that the derivative of any function over, any reciprocal of a function is the negative of the derivative of that function over that function squared. And this becomes what? Negative, the derivative of cos is negative sine over cos squared x. And this gives you sine x over cos x times 1 over cos x. And this one here is tan, and this one is sec. So a sec x tan x. So the derivative of sec x is sec x tan x. And so that is how you find the derivative. Similarly, you could find the derivative of cosec it will be 1 over sine of cot, it will be 1 over cot of x. So the derivatives in total then for all the trigonometric ratios are what? d dx of sine of x, d dx of cos of x, d dx of tan x, d dx of cosec x, d dx of sec x, d dx of cot x are what? This is cos x, this is negative sine x, this is sec squared x, and then when it comes to the reciprocals, the one for cosec x is equals to negative cosec x cot x, cosec x cot x, and then of sec x is equals to sec x tan x, and then of cot x is equals to negative cosec squared x. So one other thing, these are the derivatives of the trigonometric functions. One thing I want you to notice is all the ones with core. Look at the signs of the derivatives. They are all negative. The ones without core, they do not have negatives in their derivatives. Okay, that's something interesting to notice there. And then also the reciprocals, right? Cosec and sec. Inside them, you have what? Cosec and sec as well. And you have what? Also, cosec goes with cot and sec goes with tan. And this relationship is repeated again. On cot, we see cot x is equal to cosec squared x. And on tan, we see tan, the derivative is sec squared x. So you know tan goes with sec, cot goes with cosec. For cosec is negative cosec cot. For tan, for cot is, sec is sec x tan x. And then for tan is sec squared x cot cosec squared x. That's how you remember this. And then just remember once again, all the ratios that start with core, their derivatives have a negative. Okay, or to start with a negative. And those are the derivatives of the trigonometric functions.